Okay, so we have our first equation, well, expression I should say, containing powers. We have 3a to the power 4 by e by 5e cubed. Now if I want to simplify this statement, right, this is the purpose of most of these equations involving indices. What would I do to simplify this statement? So share your thoughts. What do you think we should do to simplify this statement? So you're going to multiply it, what you're multiplying, or what you're adding. Alright, nice. So let's multiply our bases. So in this case, we need to pay attention to the fact that we have coefficients as well as bases. Alright? So if I multiply the bases, in this case I'm multiplying 3 by 5, and then I also have to consider the base of e. Right? Now, as she mentioned, we're going to add the powers of a because we're multiplying a. In all cases here, the base is the same. So if it's the same base, we know from our laws of indices that we have to add the powers. Alright? So this is a to the power 4 plus 1 plus 3. And when we simplify this, so product of 3 and 5 gives me 15. And the power of a would be, thank you, 8. It will be 8. Right? All we have to do is add our powers. So I'm going to give you all another one, quite similar to this one. Nice. So we're going to find the product of our coefficients. And then lovely. Alright. You're missing out one little one because this one is also a 1 here. 1, 1. So I'll just add that in. But yes, so that was Turan. Turan did a lovely job for us with those indices. So thank you to Lisha and Turan. A very nice bit of teamwork too. Alright, so we get 2 by 4 is 8 and powers of x and y. Lovely. Alright, so that's how we would work out an equation. Well, I shouldn't say work out. Simplify an expression like that. Now, I have another one. I want to see what you all think about this particular statement. Alright? So the normal thing with students is that, let's say it looks like this all the time, right? You're accustomed to dealing with these. But then all of a sudden, we decide that we're going to bring something looking like this. Right. So, you're accustomed to the ones dealing with products, but now they bring something like this. What we're going to do? That's it. Over to lovely. So you wanna leave the e to the power of 3 here still? Alright, so here's what. You'll handle the coefficient very well. The reason why I asked the question about where you want to put the a to the power of 3, because here's something that we need to make notes of. Remember, these guys here all were multiplication. So that's why we could handle the multiplication. So tell me, if you had to simplify just the top alone, what would you have done with the base e? If we were dealing with top alone, where we had to do this multiplication, you'd put 3 by 4, and then what we would have outside of that. There you go, a to the 5 plus 2. Nice. Now, the reason why I asked the question, where you want to put the a cubed, is there any law that you learned about where this operation is involved. What is this operation again? What is represented by this line? Beautiful, division. So if it is, we have the same bases being divided, what do we normally do with the powers? Anybody could recall that law? Because if you could do that, then it will tell you where you're going to put this a to the power of 3, or what you're going to do with it in the first place. So tell me, what is the law involving division of the same bases raised to a power? The one with the multiplying the powers. Yeah. Okay. So let me just take a little trip down memory lane here, right? So if I have a to the power of x by a to the power of y, that's the one that we've been utilizing so far. So we know that this is a to the power of x plus y. That's how we were working out the others, right? But now I have something like this. Anybody could tell me, what do I do when I have something like this? I'm glad it does. It does, doesn't it? Does anybody recall the session where we were dealing with all the different laws? And, well, it was an extra session, and I had recorded it and left the recording up for everyone. But anybody could recall it? Do you? Do you? Tell me. Lovely. They would be. And that is correct, Stephanie. I wish I had a prize for you. But lovely. That is exactly what it is. You actually have to find the difference of the powers. So one of the things that you could think about, and the connection here, right? Multiplication is like repeated addition. So repeated addition means that you're doing the same number added to itself each time. And in the case of this multiplication now, the reason we have the index is because of we are repeatedly multiplying the same number by itself. So that's why in this case here, you add the powers, right? That's the only thing that's going to change, because you are multiplying the same number by itself however many times. Now when it comes to division, right, if you have the same bases, essentially you're counting the number of groups of that specific number in whatever this is, right? A very off the pathway that we on right now kind of discussion is, if you can recall how you convert a number from base 10 to, say, binary, for people who do IT, if you could remember that conversion, what you do to convert the base 10 number to binary, you divide the base 10 number by 2 as many times as 2 could go into that number. And it's kind of like the same thing in this case, where if I'm dividing the same bases, right, each one raised to a different power. Essentially what I'm doing here is finding how many groups of this particular number is in my a to the x. And if it's the same base, right, the result that I'm going to get, the quotient that I'm going to get from these two would actually be the base a raised to the power that is the difference between these two powers. Alright, and you can check that for yourself. Like if you have a number like 16 and you divide 16 by 4, you will get 4. And 16 is a base 2 number, 4 is a base 2 number, and the result is also a base 2 number. And you'll see for yourself that 16 to the power, 16 in base 2 is 2 to the power 4. 4 as a number in terms of base 2 is 2 to the power of 2. And that's how you end up getting it. So like I was saying just now, I'll write it down. So if I have 16, which is 2 to the power of 4, being divided by 2 to the power of 2, right? It's the same base, because the result is still going to be 4, but the powers, the difference here, 4 minus 2 gives me back that 2 to the power of 2. Alright, so if it's division, it's subtraction. If it's multiplication, it's addition of powers. So that's why it's really going to be critical for you all to make sure you have your laws of indices all written down together, and in a place where you could learn them off, right? So make sure you have your laws of indices handy. Make sure you have them on something that it's pretty clear for you to see each law, and try to find a way for you to connect it, because I might say something and it might confuse somebody, but it might make sense to somebody else. So you need to figure out the little trick that will help you in particular with being able to understand the information. All right, everybody's going to have a different little trick for themselves, but you just need to find a way that you can understand the information for yourself. All right, so simplifying this statement, right? What are we going to do with the a to the power of 3? So as we've just, taken a little detour, we said that in the case of simplifying, when we are doing division of the same bases, we find the difference of the powers. So this is what we're going to do with this to the power of 3. You're actually just going to subtract the index here. All right? So from here, you'll be able to simplify. But this is how you use your laws of indices to simplify absolutely any statement involving indices. You just need to be able to identify the law that needs to be applied and then appropriately apply it. All right? So 3 by 4 will give me 12. And I mean, if you want to work out, 12 on 2 is 6 one time, you're free to go. All right? But 12 on 2 and then e to the power of, so 5 plus 2 is 7, and 7 minus 3 gives me 4. All right? So I get the final answer as 6 e to the power of 4. All right? So I'm going to give you another one like this, because we want to make sure we understand that we can apply all our laws of indices to simplify absolutely any algebraic statement involving indices once we know which law to apply. All right? All right. Nice. Anybody? Start talking some more. What's the first thing that comes to your mind when you see this? Nice. So Shayra says she wants to cancel stuff off because, this is something that I was meaning to show you all some connection with, and I think I did in the very first session. When we have things like 2 by 2 by 2 over like 2 by 2 by 3, you could cancel off anything that's common, and that's how you all first would have encountered some laws of indices related type problems, but also you would have learned to simplify doing things like this. So you could start off by cancelling off. So what do you want to cancel off? What do we want to cancel off? Anybody? Now, she might say cancelling off, and she understands what she wants to do, but somebody else might see it a little differently, and it's the same thing. So anybody else wants to tell me what they think about doing when they see this question? That piece underneath? Yeah. All right, so you see, and both processes will still get you the same results. So let's start off with, so I'm going to put one solution up here, and I'm going to put one solution over here as well, right? So you'll see that you'll still get the same results. Okay. As Shayra was saying, Shayra said she wanted to cancel off, right? So when I think of cancelling off, I think of the fact that 14 is a product of 2 and 7, all right? And as Adina just said, we could do things like this. We could just, simplify what we have in the denominator part of things. Now, if I want to simplify what's in the denominator part of things, tell me, what will I get? There you go, 14a to the power of 7, all right? So for those of us who probably need to take it stepwise, just like we did before, right? We would write 2 by 7, and then that would be a to the power of 3 plus 4. All right, both ways, again, you're going to see that you're going to get the same result. So based on what Shaira told us, look at what we're going to remain with, right? We have no coefficients now. We just have things dealing up with these powers. All right, so this is what she left us with. And what Adina just told us, you'll see that we have a common coefficient between the terms, right? So what should we do from there? That's what you could do. Cancelling off the 14 in both parts. And that leaves us with a to the power of 5 over a to the power of 7. Right? So although this one doesn't look like that as yet, you actually do get the same exact statement, because this piece here simplifies to being a to the power of 3 plus 4, which is just a to the 7th power. So you see, 2 different pathways, but still, we're coming down to getting more or less the same answer. So tell me, what do I do from here now? I have a to the power of 5 over a to the power of 7. There we go. A to the power of 5 minus 7. That A not looking so nice, but okay. So in both cases, yeah, look at that. A to the power of 5 minus 7. What next? Lovely. So we get a to the power of minus 2. Okay. Now, although this is technically index form, we're a little fussy. We don't like to see negative powers. So anybody can recall a particular law that you would have learned involving negative powers? Anybody? Nice. So Stephanie is doing a nice finishing job for us. So if we turn this into a fraction, what will we get? Alright, so I'm going to put the answer she just gave us. She says 2 over a. Alright, so let's stick up in there and let's ask the rest of the class. Anybody else has any suggestions? Do you agree with the 2 over a, or do you think there's something else? We need to hear some voices, alright? So today I've heard from Tyron, from Adina, I've heard from Shaira, heard from Stephanie a lot, I heard from Talisha, Nadira. Anybody else? Anybody else want to contribute today? Beautiful. There we go. You know what I like about you all? When I say something, yes, you might in your mind panic, oh my god, what if I have the wrong answer? But you don't let that hit you to the point where it's like, oh my god, I don't know nothing. You start thinking back, did I really use the correct knowledge? Did I really apply this thing properly? And I like that, because you are able to reassess and find your own errors so you can fix it. And that is something that not many people are very good at doing. So she has in fact found the correct answer for us, right? And in both cases, look at that. Look at that. It simplifies exactly the same way. Both answers are the same. So this is what I always love to say. When you have a full understanding of all the things pertaining to a topic, it does not limit your ability to find alternate solutions. So I might have a particular way I want to see the solution. You might be able to get the same exact answer, but your path might be completely different from me, and somebody else might have a completely different path from both of us. So the important thing is that you are using your mathematical knowledge in the appropriate ways, and you are doing them accurately. Alright, so this is how we would solve this question 2 ways, and you still get the same answer. Now, I'm going to put one of the questions from what we were doing last time with the numbers, and let's see if you can recall how to do those. we're going to start with the very first one, which is this 2 to the 5th power by 2 to the minus 3 over 2 to the power of 2. What should we do to simplify that first statement? Nice. Mm-hmm. Mm-hmm. Okay. And you'll get 1. All right. So actually, when we do 5 minus 3, what do we get as the power? Nice. So this is exactly like she was saying. At this point, after that, you could just cancel off and you will get 1 as your answer. There's another way in which you could do this. And I just want to highlight what she did here, right? Because for multiplication, remember, it's addition of powers. But because of this negative power here, that's why she just went straight to doing a subtraction. All right. Now, again, there are so many different ways that I could tell you to do this, but this was her way of doing it, and she saw it pretty straightforward, pretty simply, and she did a really good job. As usual, my day always has some bit of noise somewhere. Anyway, so she did 2 to the power of 5 minus 3. She kept 2 to the power of 2 in the denominator. And if she wanted, she could have simply gone straight to writing this entire thing as one statement, right? So that could have given us 2 to the power of 5 minus 3 minus 2. All right, and then we put a plus. Yeah, 5 minus 3 minus 2. All right, and this would then simplify to being 2 to the power of 0, which would still give us 1. And even over here, when she mentioned cancelling off, if you wanted, again, just to use indices, you could do 2 to the power of 2 minus 2, which still gives me 2 to the power of 0, which still gives me 1. All right? So there might be a person in class who might have seen the same exact path that Kyla took and did it the same exact way. Then there might be somebody who would have started quite similarly to her, but then decided, well, I could just write everything as one statement instead of having to do all this, right? And they would still get the answer. And then somebody might have continued with this, but then at this point decide to go to use their laws of indices. So do you understand what I'm talking about? The path seems so infinite once you understand all your laws. All right? So excellent job, Kyla. Thank you very much. And one of the things that I must say with people in this class, right? There's some people who were completely new to me, but they really stepped up and really tried to find their voice and share with us how they understand things. And it's nice to see that coming down to the end of the term, even now people are still participating the same exact way, so I'm happy for that. All right, let's move to the second one, which depending on how you view it might be a little extra challenging, right? But it is slightly more difficult than the previous. So who'd like to tell me what is the first thing that comes to your mind when you look at that particular statement? Let's go with that, right? In the meantime, I want you all to think, what can you apply here, right? I'm sure some people might see a different route for themselves. So Kyla says, let's turn 25 into 5 to the power of 2. And I like this approach because this actually can help simplify some of the most complicated of problems. Your ability to recognize what a number can be expressed as in its index form. All right, what next should we do? Gail can help her out. She already started off with a nice idea here. Anybody? Tell me. Nice. Look at that. See? So you could do a to the power of 2 here, right? And this would give me to the power of, well, I still have that minus 1/3. Alright, so this is good. This a to the power of 2 is good. And in a little bit, I'm going to show you another way as well that you could approach it. And for the sake of making your, problem solving a little bit easier for you, I'll show you another way as well that even from here, you're going to be able to, you'll see for yourself, you'll be able to get it back on track. All right, what are you going to do from here now? Yes? Lovely. That is what I was not going to say, right? That's what I was mentioning just now. To make your problem solving a lot easier, right? What you could look at is this. So when Kyla said she was changing 25 to 5 to the power of 2, if you look at the power outside here, right, this to the power of a half, this will kind of tell you, well, okay, if you bring this number inside it to the power of 2, it's going to make your job simplifying a little easier. So now if you look at this power, it's to the power of minus 1/3. But if we change it to a to the power of 2, all right, when we apply the lowest of indices here in a little bit, this would still leave us with a fractional index. And what we usually would prefer is to get rid of these fractions, all right? So what Turon did here, it could still be fixed, right? As in, you could still get rid of the fractional index in a pretty simple way in a little bit and still be able to work it out with no trouble. Alright, but as Adina just said, we could change it to 4 to the power of 3 because 64 is the same as 4 cubed, and that is going to help us with getting rid of that 1/3 like nothing. Okay, so I'll write the other way of doing the solution right here. Okay, so instead of using 8, we'll use 4 to the power of 3. And we'll get this to simplify a little differently. Alright, so like I was saying, this is not wrong. It still can be worked out. It still can be evaluated. It just might mean you're going to have a little extra thinking, right? And for those of us who might like look at this and then when you see the fractional index and be like, oh my goodness, it still is a fraction, and how am I supposed to simplify this now? It can still work out. Alright, so if you're the type of person who might panic when things don't really simplify, try to match the power of the number that you're changing to index form to the power of the same denominator as the base outside. Alright, so over here now we can apply a particular law and everything here going to simplify. So anybody want to tell me what we're going to apply here to simplify the statement? We can do the one in red right now. What will we apply here to simplify this statement? Quick question. Anybody remembers what we do when we have a to the power of x to the power of y? Anybody? Beautiful. You'll multiply your indices. So this is actually the one that I want you all to apply here in this entire statement. Alright, so anytime you see power raised to a further power, this is the law that you need to think about applying. Alright, so what will we get when we apply this law to this statement? So think about it, right? Stephanie just gave you all a nice head start with figuring out what to do. Ah, lovely. Thank you, Adina. And that's correct. you just multiply 5 to the power of 2. So the multiplying in the indices, right? 2 by a half would just give me what? 1, right? So you could leave it as 5 as is, and that's perfectly fine. Or if you're the type of person you want to write to the power of 1, you could write in the power of 1. That's your choice, all right? But I'll just leave it as 5 because I understand that's to the power of 1 already. And then what happens here? 4 to the power of 3 to the power of minus 1/3. What do I get? Anybody? What will we get? Come on, come on. Yeah, it's going to be -1. It will be -1. So this probably highlights for some of us who feel a little not so confident in our abilities to work with fractions. Definitely spend a little time reviewing those things, right? How to do your arithmetic with fractions. Because once you could do, trust me, laws of indices, while it is one of the foundational things in algebra, it has so much arithmetic in it. So if you are capable of doing arithmetic with absolutely any number, you'll be able to simplify absolutely any index statement. Okay? So the next thing that we can do here now, we can further simplify this, right? 5 by 4 to the -1. Anybody wants to tell me what they will do to work this out? Simplify it, right? The final statement. What do we do from here? Anybody? Alright, so as she mentioned, power of -1. Alright, so to help her out a little bit, so Tiran, here's something that I want you to look at. Where's the power of -1? Is it on the entire product, or is it just on one term? Right, just on one. So what I want you to do is that same thing that you said you're going to do, apply it on just the one term. So what we'll get instead? So I know earlier you were saying you're going to do 1/20, but if it's only applied to the 4. Anybody? If you understand what we're doing here. We have 5 by 4 to the power of -1. What should we do? Nice. And that's all we're doing. Alright? So 5 multiplied by 1/4. Alright? So that's what I was saying. She knew what she wanted to do. All she had to do was apply it just to the 4. So you'll get 5 by 1/4. And that's just going to give us 5/4, and you can leave your answer like that. Alright? 5/4. So, like I was saying earlier, with this a to the power of 2, this could still work out and get that same 5/4. Alright? So, here's how you do that. Now, you can change this 8 to the power of 2. Okay, so at this point, right, as we have the statement, what you'll notice, like I was saying, is that you could rewrite the 8 as base 2 instead. So this 8 can be written as 2 to the power of 3, and since it's 8 squared, you'd end up writing something looking like this. Alright? So you might look at it and you might be like, but there's so much indices. But all you actually have to do here is just know how to apply that law that we talked about, which is multiplying the powers. If something is already raised to the power and you have it raised to another power, you just multiply the powers. So you'll still get the 5 to the power of 1 over here, And then this would be 2 to the power of 3 by 2 by minus 1/3, which will simplify and still just simply give us this raised to the power of 2. Okay, because 3 by 2 is 6, and 6 on negative 2, sorry. 2 by 3 is 6. 6 by negative 1/3 is just going to leave us with a minus 2. And when we simplify this using the law that relates to negative powers, you'll get 5 over 2 to the power of 2, which is the same as 5 to the power of 4. 5 on 4, sorry. 5 on 4. It's in madness. But yeah, both ways still simplified and gave you the same results. Okay? So whichever way you're more comfortable with, as usual, you just need to know yourself. You just need to know, okay, am I comfortable working with something that looks like this? Or am I more comfortable working with the other way that we looked at? Alright? That's all up to you. So we do have one more session, Thursday. Alright? We do have to learn how to do indices to solve for missing values where the power is the unknown. And what I would encourage you all to do is just make sure that you refresh your memory on all the laws of indices. So when we come together again on Thursday, you'd feel a bit better about being able to apply the rules to solve absolutely any problem involving indices. Okay? So that's it for today. We are at that time where I need to let you all go. So do enjoy the rest of your day, everybody.